Earthquakes, volcanoes, tsunamis, all these destructive forces of nature have something in common that most people don't know. They're just symptoms of something much bigger happening deep inside our planet. Earth is literally rebuilding itself all the time, like a living machine that never rests. Pieces the size of entire countries are colliding with each other right now, creating mountains. Others are pulling apart, opening new oceans, and some are diving back into Earth's hot interior to be melted and recycled. This incredible process has been happening for billions of years and created everything we see on the surface, from the highest mountains to the deepest ocean trenches. But the most surprising discovery of all changed how we understand our planet. Without this planetary recycling system, life as we know it could never have existed. How can something so violent and destructive also be what keeps our planet alive? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. Have you ever wondered if the ground you walk on is truly still? Many people think the earth under our feet never moves. It feels hard and solid. You can jump, you can build on it, and it does not shake or move most of the time. But this is only part of the story. In reality, the Earth's surface is not as steady or still as it seems. It is made of giant parts, each moving very slowly. These are called tectonic plates. Tectonic plates are massive slabs of rock. They are much bigger than a city, a country, or even a continent. Some of them are bigger than the entire Atlantic Ocean. These plates fit together to cover the whole surface of the planet, like pieces of a puzzle. The biggest plate carries the Pacific Ocean. Others carry Africa, Europe, Asia, and the Americas. There are many plates, but about 7 main plates cover most of the Earth. Between these plates are something called boundaries. A boundary is simply the place where 2 plates meet. These boundaries can be on land, under the sea, or under mountains. Sometimes you do not see them at all because they are hidden deep below the surface. Still, these invisible lines are very important. Many of the world's biggest and most amazing natural events begin at these boundaries. Most of the time, you do not feel the ground move. The plates move very, very slowly. If you sat and watched the ground all day, all year, you still would not see it move. The plates move only a few centimeters in an entire year. That is less than the length of your finger in 12 months. Even though the plates move so slowly, over thousands or millions of years, this movement adds up. It changes the face of the Earth. The continents and oceans do not sit on top of one solid piece of rock. They rest on top of different plates. Each plate can carry part of a continent, part of an ocean, or both. Imagine a giant table, and each plate is a piece of wood on that table. The pieces can move and change their places. Because of this, the land and sea above them also move. That is why the shape of the continents and the oceans changes slowly, but always. The crust of the Earth is the layer we all stand on. It is very thin when compared to the size of the planet. Most of it is only about 30 kilometers thick where there is land. This is not far if you compare it to how wide the Earth is. The crust is thick under mountains and thinner at the very bottom of the oceans. Below the crust, the Earth is very hot. The hot layer below is soft and moves slowly, almost like warm dough. The plates float on top of this hot, moving layer. The plates themselves are hard and strong on the outside. They are made from rock that does not bend easily. But because the layer under them is hot and soft, the plates can slowly slide, bump, or pull apart from each other. This movement is what causes some of the biggest changes to the land and the oceans. Sometimes the plates move together and hit each other. When they do, one plate can go under the other, or they can both crumple upward. Other times, the plates move apart. Gaps appear and are filled with new material from deep inside the Earth. And sometimes the plates slide past one another, rubbing along the cracks called faults. Each type of movement at these boundaries creates different changes above ground. These tiny movements do not stop. They happen all the time, though so slowly that only very special machines can measure them. Scientists use tools called GPS receivers and other sensors to track how fast and in what direction each plate is moving. Long ago, nobody knew that the ground moved. Now we know it never truly stays still. The idea that the Earth is made of moving plates helps us understand so much about our planet. It explains many things that people used to find mysterious or puzzling. For example, why are there mountains far from the sea? Why do earthquakes happen in some places but never in others? Why do volcanoes often pop up in lines or rows near each other? Why do the shapes of the continents seem in some ways like they could fit together, like Africa and South America? Today, we know the answer is that the surface is moving very slowly all the time. Over a very long time, the movement of the plates has caused continents to drift across the surface of the world. Hundreds of millions of years ago, all the continents were once joined together in a single, huge continent. Scientists call this ancient continent Pangaea. After many millions of years, Pangaea split apart as the plates moved. The pieces drifted away from each other and formed the continents we see now. The process is slow, but never stops. If you could travel back in time by 500 million years, you would see continents in different places than they are today. Land that is now covered by sea might have been high and dry, and places now deep below the waves may once have been mountains. The ground under your feet has not always been in the same part of the world. In the distant future, the continents will continue to move and change places. One day, they might even come back together to form a new supercontinent. All of this is possible because the surface of the Earth is not fixed. The slow movement of plates changes everything on the surface. Huge mountain ranges get built up and then worn down. New land forms and old land disappears. The floor of the oceans grows wider in some places and smaller in others. Even the edges of the continents, where land meets sea, move back and forth over the years. Nothing stays in exactly the same place forever. This knowledge also tells us that even very old rocks, high mountains, or deep ocean trenches are only temporary features in the life of the planet. The plates are always making and breaking the shapes of our world. The force that moves the plates comes from deep inside the Earth. The center of the Earth is extremely hot, much hotter than the crust. This heat comes from when the planet first formed and from the slow breakdown of some elements that release energy. The deep heat makes the rocks under the plates flow very slowly, but they are nothing like water. It is more like very hot, soft rock that takes thousands of years to move at all. The plates ride on this soft, moving layer. The heat in the deep earth rises, pushing up under the plates. Sometimes the heat moves in big flows, slowly pushing the plates apart or pulling them together. This is the main reason the surface of the Earth does not look the same forever. The heat never stops, so the plates never stop moving. Many natural events are linked to the plates. The movement causes earthquakes. When the plates press against each other, sometimes they get stuck. When they finally break apart, the ground shakes. This is an earthquake. Earthquakes can break apart roads, houses, and even whole cities. They happen most often at the places where plates meet. Volcanoes are also connected to the moving plates. When one plate slides under another, rock melts because it gets very hot. This melted rock can rise up through cracks. If it makes it to the surface, it explodes out as lava and ash. Volcanoes often appear in lines where two plates meet, such as the edge of the Pacific Ocean. These lines are sometimes called rings of fire because there are so many volcanoes there. Not all the movement is dangerous. The movement of plates also makes new land. Where two plates move apart, hot rock from below fills the gap. When this rock cools, it becomes new seafloor. Over millions of years, new land is created and the oceans get bigger. This slow creation and destruction of land keeps the world changing. Mountains are also linked to the movement of plates. When two plates push together and neither goes under the other, the rock is crumpled and pushed up. Huge mountain ranges like the Himalayas are created this way. These mountains are some of the highest places on Earth, and even today they keep getting higher bit by bit as the plates keep moving. Deep down in the oceans, the movement of plates makes trenches, which are the lowest places in the world. These are formed when one plate goes under another in the ocean. Our planet has some of the deepest places, much deeper than any valley on land, hidden in these sea trenches. The process of plates moving and changing the surface is called plate tectonics. Plate tectonics is the reason we have earthquakes, volcanoes, mountains, and deep ocean valleys. It is the reason the shapes of the continents and oceans are always a little different with every passing year. If you could watch the planet from far away for many millions of years, you would see the continents drift, break up, and join together again and again. We often think the Earth is unchanging and steady. We measure our lives in days, months, and years. But the ground under us is part of a story that takes millions of years to unfold. With each slow movement, the plates shape the world in ways that can be seen today and leave clues about how it was long ago. The more scientists study tectonic plates, the more we understand about our world. We know now why landforms appear where they do, why natural disasters strike certain areas, and how living things have adapted to a world that never stays exactly the same. Knowledge about plates helps people build safer homes in places with earthquakes and helps them understand where it is safe to live. So, even though it feels like nothing changes under our feet, the truth is different. The ground beneath us is always on the move, slowly, quietly, but always. This simple fact explains many of Earth's biggest mysteries. It is why there are mountains, why the ocean floor is always being remade, and why the land around us keeps its shape only for a while. The ground may feel still to you now, but deep beneath you, the real world never stops moving. The story of the Earth's plates is the story of a planet in motion, always making and remaking the places we call home. Deep underground, the Earth holds many secrets. If you could somehow travel below the ground you see every day, you would find that the world down there is not cold and hard. It is warm and alive, with forces moving that you cannot see or feel from the surface. This heat deep inside our planet is the reason why huge rocks above can move at all. The warmth is powerful and ancient. It has shaped the Earth since the planet first formed a very long time ago. The inside of the Earth is made of several layers. On the very top is the crust. The crust is the ground where people live, walk, and build things. Below it is the mantle, which is much hotter and thicker. Most of the mantle is solid rock, but some parts are so hot that the rock is soft and can slowly move. Even deeper, there is a core. The core is in the very center of the planet, thousands of kilometers below your feet. The core is hotter than any oven or fire. Part of the core is made of liquid metal, and the very middle is a hard ball made mostly of iron. The heat from the deep earth makes everything above it move, even though it does so very slowly. Most of this heat comes from when the earth was just beginning. Long ago, pieces of rock and dust crashed into each other in space and stuck together because of gravity. When this happened, huge amounts of energy were released, and this energy is still trapped inside the planet even today. There is also heat because some particles in the rocks break apart and release energy. These are called radioactive elements. They break apart very slowly and add heat to the inside of the Earth year after year. This heat cannot escape quickly because the Earth is very big and rocks do not send heat through them easily. Over a long time, however, some of this warmth rises slowly toward the surface. It moves like a slow flow, carrying heat from the deepest parts upward. This flow is strongest in the mantle, which sits just below the solid crust. The mantle is not like air or water. Most of it is rock that can bend and move very slowly if there is enough heat. When this hot material pushes upward, it helps move the tectonic plates that float on top. The way the mantle moves is called convection. Convection is a process where hot material rises because it is lighter, and cooler material sinks because it is heavier. As hot rock in the mantle warms up, it rises toward the crust. When it gets closer to the surface, the rock cools down a little and sinks again. This makes a kind of endless cycle, with rock flowing very slowly up and down. These slow-moving flows carry heat from the deep mantle up to the crust and help push the tectonic plates around the planet. The crust and the very top part of the mantle together are called the lithosphere. This layer is hard and breaks into the plates that move. Underneath the lithosphere is a layer called the asthenosphere. The asthenosphere is softer and flows more easily. The plates of the lithosphere float on this soft-moving asthenosphere. They are pulled and pushed by the slow movement of the rock below. The speed of this movement is very slow, but it is enough to change the whole surface of the planet. A single plate might move only a few centimeters in a year. This is less than the width of an adult's hand. In 100 years, that is only a few meters. But in 1,000,000 years, the plates can move far across the Earth, changing where the continents and oceans are. This process is the driving force behind the changing face of the planet. When the hot mantle rises and pushes against the bottom of a tectonic plate, it can make the plate move away from other plates. Where the mantle sinks downward, it can pull a plate down with it. Sometimes the movement is strong enough to break a plate into two smaller pieces. The movement of plates is never exactly the same everywhere at once. It is a slow and steady process. Over many thousands and millions of years, this small movement adds up to huge changes. There are also special places where the heat from the deep Earth rises very strongly, such as under some islands in the ocean. In these spots, called hotspots, the heat can melt the rock directly under the plate. When this happens, volcanoes can form even in the middle of a plate, far from where plates meet. These volcanoes slowly build giant mountains under the sea, and sometimes new islands appear above the water when lava piles up high enough. The slow movement of hot rock in the mantle shapes the world in many ways. As heat rises, it can stretch the crust and cause it to break open. When this happens on the ocean floor, new crust forms from melted rock that cools and becomes solid. This new land pushes the older crust away, making the ocean wider. When parts of the mantle sink, they can pull the crust down with them. This is one reason why deep ocean trenches form and why some plates are slowly pulled beneath others. Earthquakes and volcanoes are both linked to this deep heat and the movement it causes. An earthquake happens when two plates stick together as they try to move. The plates can only bend a little before they break free, and this sudden movement shakes the ground above. Volcanoes form when hot rock melts and rises to the surface, breaking out as lava, ash, and gas. Most volcanoes are found where plates meet, but some are created by the direct heat of a hot spot in the middle of a plate, far from the edges. The movement of the plates also moves the continents. Over millions and millions of years, continents travel over the surface of the planet. Sometimes they crash into each other and form high mountains. Other times they break apart and drift away from each other, making new oceans between them. The movement never stops. The continents have changed shape and position many times in the long history of Earth, and they will keep changing in the future. Because the rock deep inside the planet moves so slowly, and because the plates are very big, it is hard for people to see these changes in their own lives. But if you look at rocks, fossils, and the shape of the lands and seas, you can see clues about how the plates have changed over time. For example, similar fossils have been found in places far apart from each other, like Africa and South America. This means these places were once joined together. This deep movement inside the Earth helps make mountains, valleys, volcanoes, and even the deepest places in the ocean. It is also important for life. When hot rock brings new elements to the surface, it makes the land rich so plants and animals can grow. The slow movement of plates helps control the climate on Earth because it affects where mountains are, how oceans and winds move, and where rain falls. You cannot feel the heat and movement under your feet, but it is always working, slowly and quietly. This process is so important that without it, the world would be very different. There would be no high mountains, no volcanoes, and no big changes in where the continents or oceans sit. Even though these forces are very powerful, they are almost invisible to us in daily life. Sometimes, in special places, you can see signs of them. In some parts of the world, hot water and steam can rise out of the ground. These are called hot springs or geysers. They show that the deep heat of the planet is not far below the surface in those places. Scientists study rocks and use machines to learn more about the heat inside the planet. They measure how the ground shakes during earthquakes to find out how the plates move. They drill deep into the ground to collect samples of rock. They watch volcanoes and measure how fast the land moves using satellites in space. Every year, new discoveries are made about how the deep heat of the planet keeps everything moving. Not all parts of the crust and mantle are the same. The crust under the ocean is thinner and made of different rock than the crust under the continents. Oceanic crust is heavier, and when it meets the lighter, thicker continental crust, the differences help decide how the plates move at the edges. This is why so many volcanoes, earthquakes, and mountains form at plate boundaries between ocean and land. The forces from the deep earth can change direction and strength over many thousands and millions of years. Sometimes what was once a high mountain becomes a quiet plain, and sometimes new mountains rise where there were none before. These shifts are not always smooth. Sometimes the plates get stuck and release energy suddenly, making the ground shake. Because the deep earth is always hot and moving, the surface of the planet never stops changing. You can see the results today in the jagged lines of mountains, the cracks in the ground, the islands rising from the ocean, and the hot lava that sometimes pours out of volcanoes. These are all signs of a planet that is alive under the surface. The slow flow of material in the mantle also helps mix the inside of the Earth. This mixing brings chemicals from deep below up to the surface. When volcanoes erupt, they bring gases and materials that help make the air and the land better for living things. The deep movement helps keep Earth a good place for life. All these changes are possible only because of the deep heat that pushes and pulls on the plates above. Without this constant movement below the surface, the land would be flat and dead. The planet would not have the rich soil, high mountains, wide oceans, or changing weather that we see and need today. The engine that runs the movement of the plates is simple but strong. It is driven by the heat left over from when the Earth was made, by the slow breakdown of radioactive elements and by the never-ending push and pull between the crust, mantle, and core. Every part of the planet, from the highest mountain to the deepest sea, is touched by these deep forces. The never-ending movement is not just about making earthquakes and volcanoes, it helps keep the planet healthy and ready for life. When new land forms, old land is recycled into the deep earth. This recycling brings fresh rock and new chemicals to the surface, creating new places for life to grow. It also removes old rocks and keeps the surface changing, which is needed for rain and rivers and for making new places for plants and animals to live. This is why the deep heat inside the planet is so important. It shapes everything, even though you cannot see it directly. From the tallest peaks down to the sea floor, and from the deserts to green forests, all are made possible by the slow, steady movement that comes from deep within the earth. The story of the planet is written in these movements, in the mountains that once were part of the sea, in the valleys that were once high ground, and in the rocks that carry the memory of a moving world. The crust, which is the very top layer of the earth, is filled with changes caused by the movement deep below. The action does not stop. These movements have a name. They are called plate tectonics. Plate tectonics is the name for the slow and steady motion of the huge pieces of rock that make up the surface of our planet. These pieces are the tectonic plates, and their quiet but constant movement is what shapes the world you see. Every continent, every ocean, every mountain, and every deep sea trench is connected to the story of plate tectonics. This movement is always happening everywhere on Earth, even if you cannot feel it. The plates glide very slowly, resting on the soft and hotter rock beneath them. The movement is slow, but over a long time it can move continents, create new land, and destroy old land. There are many tectonic plates, but the biggest ones are very large. Some carry whole continents. For example, the African plate carries all of Africa. The Pacific plate sits under the Pacific Ocean. The South American plate holds South America. The North American plate carries North America and part of the Atlantic Ocean floor. Other plates hold Europe, Asia, Australia, and Antarctica. There are some smaller plates too near the edges of the big ones. All these plates fit together, covering the Earth's surface, but there are lines where the plates meet. These lines are called plate boundaries. Plate boundaries are found on land and under the sea. They are the places where the most change takes place. The whole process of plate tectonics explains why land and sea never stay the same. For many years, people did not know this. Long ago, scientists noticed that the east coast of South America and the west coast of Africa looked like they could fit together. The rocks and fossils from these two places were also very similar. This was a mystery until people understood plate tectonics. Now, scientists know the continents move because they ride on top of plates. Over millions of years, the continents have joined, separated, and moved across the planet. Sometimes there were supercontinents, which were very large continents made from smaller ones joining together. One such supercontinent was called Pangaea. As the plates continued to move, Pangaea broke into the continents we see today. Plate tectonics is not just about moving continents. Every kind of landform we see, mountains, volcanoes, valleys, ocean trenches, and large flat plains, is shaped by the action of the plates. When plates meet and push together, land can rise up to form mountains. When plates move apart, space opens for new land to form. When plates slide past each other or get stuck, earthquakes shake the ground. The movement of tectonic plates can be very small each year. A plate can move just a few centimeters in 1 year. That is about as much as your fingernail grows in a whole year. But after thousands or even millions of years, that tiny movement adds up. Mountains become higher. Oceans become wider. Continents move far from where they began. Where two plates meet, the land is full of energy. All plate boundaries are interesting because important things happen there. At plate boundaries, you find earthquakes, volcanoes, and even the creation of new land or the destruction of old land. Not all boundaries are the same, though. There are three main types of plate boundaries, each with its own kind of action. The first type is a boundary where plates move toward each other. These are called convergent boundaries. Here, the plates squeeze against each other. In some places, one plate goes under the other. This is called subduction. In other places, they both push up, making mountains. The second type is a boundary where plates move away from each other. These are called divergent boundaries. Here, new land forms between the plates as melted rock from below rises and cools down. Most divergent boundaries are found on the bottom of the oceans. The third type is a boundary where plates slide past each other. These are called transform boundaries. The plates scrape against each other. Sometimes they get stuck and then slip suddenly, causing earthquakes. No matter which type of boundary, the result is always energy and change. Some of the world's greatest natural events begin at these boundaries. Most volcanoes and earthquakes are found near the edges of the tectonic plates because this is where the plates touch and move in different ways. Plate tectonics also tells us why the surface of the Earth is always new. Old crust is pushed down and melted inside the Earth. New crust is made from melted rock that cools on the surface. This process is a kind of recycling. In one place, old land goes back into the planet. In another, new land forms and rises above the sea. This cycling makes the Earth's surface active. It means that the highest mountain today can become a flat plain in the future, and a deep ocean can rise up to become dry land. The plates control not just the look of the land, but also where water collects, where volcanoes explode, and where earthquakes shake the ground. The places where the plates meet are often marked by lines of high mountains, long trenches in the deep sea, or chains of islands made by volcanoes. The Himalayas, a high mountain range in Asia, were formed because two plates pressed together and crumpled upward. The Andes Mountains in South America also began when two plates collided, but in that case one plate went beneath the other, creating volcanoes along the edge. On the ocean floor, the longest mountain chains in the world stretch for thousands of kilometers. These are called mid-ocean ridges. They form where two plates are pulling apart. Melted rock rises up, cools, and makes new land. The Atlantic Ocean, for example, is growing wider because new land is forming in the middle, deep below the waves. All over the world, scientists study how the plates move and what results from their action. They use maps, satellites, and instruments that sense the smallest shakes in the ground. This helps people understand where it is safe to build, where to expect earthquakes, and how volcanoes work. By studying rocks and landforms, scientists see evidence of past plate movements. Fossils, for example, can be found high in the mountains, even though these animals once lived on the ocean floor. This proves that land can rise up from the sea when plates move. Many islands are made from volcanoes. These islands rise from the sea where melted rock comes out and hardens. Sometimes chains of islands are made when a plate moves over a hot spot where heat rises from deep inside the Earth. The islands of Hawaii are examples of this. Plate tectonics is also important for life. When plates move and volcanoes erupt, they bring new chemicals and minerals from deep inside the planet. These new materials can make the soil rich for plants and animals. The movement of plates changes where mountains and valleys are, which changes the climate. The rain patterns and wind directions also change, affecting where plants can grow and where people can live. Another important effect of plate tectonics is that it controls how much carbon dioxide and other gases are in the air over very long times. Volcanoes can put gases into the air, and rain and rivers can carry them away when new lands are made. This helps keep the Earth ready for life, never too hot or too cold for living things. The plates also help water move across the surface. When high mountains form, they catch rain and snow, which flows down as rivers. These rivers help bring fresh water to plants, animals, and people. The shape of the land, the mountains, basins, plains, and valleys, all depend on how the plates have pushed or pulled over millions of years. Because the plates do not move at the same speed or in the same direction, they sometimes break or split. When a plate breaks, new boundaries form, creating places for even more change. For example, long cracks called rifts can form in the land, making deep valleys. Over time, these rifts can become new oceans. The African continent is slowly splitting along a huge crack called the East African Rift. One day, many millions of years from now, this could become a new ocean as the plates pull apart and new land forms. These changes are slow, but they shape whole continents and seas. Under the ocean, plates can meet and one slides under the other. This makes deep trenches in the sea floor, like the Mariana Trench, which is the deepest place on Earth. These trenches are made by plate tectonics and are so deep that only special machines can explore them. Plate tectonics not only makes new places, it also destroys old ones. When a plate is pushed down beneath another, the old plate melts and becomes part of the deep earth again. This makes space for new crust to form somewhere else, keeping Earth's surface fresh and changing. All these movements and changes mean that the world does not stay the same for long, at least not in the time of the planet. Mountains rise, oceans widen or close, islands form, and continents move. Life must always adapt to new places and new climates. Earthquakes, volcanoes, and the rise of mountains might seem scary or dangerous, but they are all signs of a planet that is alive and active, not frozen and unmoving. Without the slow but steady movement of plates, our planet would not have high mountains, deep oceans, or rich lands for plants and animals. Understanding plate tectonics helps people stay safe. Scientists use what they know about the plates to make better decisions about building cities and roads, especially in places where earthquakes can happen. Knowing how and where the plates move can save lives and help us learn more about the history and future of the Earth. The science of plate tectonics shows that our planet is always being rebuilt every day. Even if you cannot see or feel the movement, everything on the surface, from mountain tops to sea floors, from cities to wild forests, is connected to the slow, steady action of tectonic plates below. The story of the Earth is written in these movements, in the rocks, in the land, and in the shape of every continent and ocean that covers our world. One of the most powerful ways the movement of tectonic plates shapes the world is when two plates push into each other and collide. The places where this happens are some of the most active and dramatic spots on Earth. When these plates meet, many important events can take place, changing not only the land, but also life above. When two plates move toward each other, they cannot pass through each other because they are made of rock, even if these rocks are sometimes hot and able to bend a little. Because of this, something must happen when they meet. In some cases, one of the plates, usually the heavier one, bends down and goes beneath the other. This action is called subduction. Subduction is a word that means one plate sliding below another plate. Subduction is very important for Earth because it is one of the main ways the ground is recycled. The plate that goes down into the Earth slowly melts as it gets deeper because everything below is very hot. Rock that melts forms a thick material called magma. Once it melts, this magma can start to rise again. It is pushed upward by the heat and pressure below. This process, where one plate goes down and melts, does not happen everywhere. It most often takes place at the edge of continents, especially where the ocean floor meets the land. The crust under the ocean is heavier than the crust under continents. When oceanic crust and continental crust meet, the ocean plate is usually the one that sinks. This is why many of the planet's volcanoes are found along the coastlines where ocean meets land, like along the edge of the Pacific Ocean. As the ocean plate sinks into the deep earth, and as it melts, some of the magma finds cracks to move through. It starts making its way back to the surface. If the magma has a path all the way up, it can collect in large pools close to the surface. Over time, the pressure from new, rising magma grows stronger. When the pressure is great enough, the magma bursts out of the surface. This is called a volcanic eruption. A volcanic eruption can be very simple, with lava slowly pouring out and cooling into new rock, or it can be very violent, exploding with ash, hot rocks, and gases. The kind of eruption depends on how thick the magma is and how much gas is trapped inside it. Some volcanoes erupt with thick, slow lava. Others explode with ash and gas that shoot far into the sky. When a volcano erupts, the land around it can change very quickly. Lava flows can cover fields, forests, and everything in their path. New land can be created right away. After the eruption, the lava cools and hardens into new rock. Over time, these rocks build up and make mountains. Some of the Earth's tallest and most famous mountains have been made by many eruptions piling up layers of rock year after year, century after century. Volcanoes are found in many parts of the world. Many of them are near the edges of the largest plates or along deep sea trenches where subduction happens. The Ring of Fire, which is a long line of volcanoes around the Pacific Ocean, is famous for having many volcanoes and for having lots of earthquakes. This is because many plates meet in this area, and they are always pressing against each other, with some of the plates sinking and melting. When magma from below the Earth rises and erupts as lava, it also brings new materials to the surface. These materials have been deep inside the Earth for a very long time. They include minerals and gases that are important for life. When the lava and ash break down, they make the soil rich and good for plants to grow. That is why some areas around volcanoes have thick forests or strong, healthy crops, even though the volcanoes can be very dangerous. Sometimes ash from very big volcanic eruptions can travel far. The wind takes the ash and spreads it over wide areas. This can block out sunlight for days, making the air dark and cool. In the past, very large eruptions have even changed the weather for many months or even years, making places much cooler and changing how much food plants could grow. Volcanic eruptions can destroy everything nearby, but they also make new land. Some islands in the ocean are volcanoes that started growing underwater. After many eruptions, the piled-up lava grew higher than the sea and created new islands. The islands of Japan, for example, are a group of large and small islands mostly made by this volcanic process. The same is true for other island groups in the Pacific Ocean. Subduction does not only make volcanoes, it can also cause very powerful earthquakes. When two plates are being pushed together, they do not slide smoothly. Instead, they often press, pull, and get stuck. Energy builds up, and when it is too much, the plates slide suddenly. This makes the ground shake. The biggest earthquakes often happen near subduction zones. Some of the largest earthquakes in history have happened in places where subduction is active. These earthquakes can move the land up, down, or sideways. Sometimes the ocean floor moves and causes huge waves called tsunamis. A tsunami is a tall, fast wave that can travel very far from the place where the earthquake happened. When it comes to land, it can cause flooding and destroy buildings, roads, and plants. Subduction zones are some of the most carefully watched places on Earth because both volcanoes and earthquakes can happen there. Scientists use many tools to watch the ground, measure how it is moving, and listen for tiny shakes that might be a sign of a bigger earthquake. People who live near these boundaries are taught how to stay safe in case of an earthquake or volcanic eruption. Even though subduction zones can be dangerous, they are also very important for the planet. Without them, there would be no way for the crust to be recycled. Old ocean floor goes down, melts, and helps create new volcanoes and land. This constant recycling makes Earth's surface active and keeps the land fresh. When one plate dives below another, it is not only the crust that is recycled. Sometimes parts of the top plate are pushed up. These pushed-up parts create mountain ranges and high hills near the plate boundary. As one plate is forced down and melts, it pulls the edge of the other plate up with it. This is why some of the world's largest mountains and tallest volcanoes are found right next to areas where subduction is happening. The Andes, a long mountain range on the west side of South America, are a good example. This whole mountain range was made because one plate in the Pacific Ocean is sliding under the South American plate. Where the plates meet, the land is rising, volcanoes are forming, and earthquakes are often felt. In the ocean, subduction forms deep trenches. These trenches are the deepest parts of the world's oceans. The Mariana Trench in the western Pacific Ocean is the deepest place found on Earth. You would have to stack many mountains on top of each other to reach up from the bottom of this trench to sea level. This trench was made because an oceanic plate is sinking deep under another plate, creating a long gouge in the sea floor. All these results of subduction, volcanoes, earthquakes, mountains, and trenches, are part of the changes caused by moving plates. These changes can happen slowly over millions of years, or suddenly in a single day because of an earthquake or eruption. Other kinds of plate collisions can also make huge changes. When two plates with land crash into each other, neither one can slide under the other easily. Instead, the land between them rises up and crumples. This process can build some of the planet's highest mountain ranges. Over a very long time, the plates press together, push rock higher and higher, and make new peaks. The Himalayas in Asia were formed this way. Even today, the Himalayas get a little bit taller every year. Not all volcanoes are made by subduction. Some are made where the Earth's crust is weak or thin, and magma can rise through cracks. But subduction zones are the places with the greatest number of active volcanoes. The heat, the pressure, and the melting rock combine to make these areas full of action. As plates keep moving, subduction zones change shape. Sometimes, a new area of subduction will start. Other times, an old subduction zone might die out if the movement slows or stops. Over millions of years, the places on Earth with volcanoes and earthquakes can move from one place to another. Subduction zones and the volcanoes they cause are not just important for land on Earth. They also play a role in the water and air. When volcanoes erupt, they send water vapor, carbon dioxide, and other gases into the air. This has happened for billions of years. These gases become part of the atmosphere, which is the air we breathe. The water vapor can become rain or snow. The minerals and chemicals in the lava can end up in rivers, lakes, and oceans. This helps keep the cycles of water, air, and land in balance. The process of subduction and the rising of new volcanic mountains continue to shape the look and the life of the planet. Whole continents can rise a little or sink a little because of the action where plates meet. Life adapts to these changes. Plants and animals move to new places, or new kinds of life can appear as the land changes. Not everything from subduction is seen right away. Many of the changes take millions of years. Old mountains are worn down by wind and rain, and new mountains slowly grow from below as plates keep moving. Volcanoes can be quiet for hundreds or thousands of years and then suddenly have a big eruption. People use knowledge about subduction for many reasons. Engineers use it to build safer buildings and prepare cities for earthquakes. Farmers watch the land around volcanoes because the soil there is rich. Scientists learn how gases from eruptions affect the air and weather. Sometimes, subduction leads to strange changes in the sea. The ocean floor near subduction zones can rise or fall, making the water deeper or more shallow. These changes can affect ships, fish, and every form of life in the ocean. The pattern of mountain ranges, volcanoes, deep sea trenches, and earthquakes across the globe shows the power of plates that crash and pull beneath the edges of continents and oceans. These patterns are not random. They follow the places where subduction takes place. Looking at a map of the world shows that earthquakes and volcanoes are not spread out evenly. They are grouped around the edges of plates, especially at subduction zones. This is how scientists know where to be most careful and where to watch the ground for signs of change. Subduction is not just a local event. It connects countries, oceans, and climates. It makes forests on the slopes of volcanoes and shapes the valleys below mountain ranges. Without subduction, the Earth would look very different. The planet would have fewer mountains and volcanoes, and it would not recycle the surface as quickly. The exchange of rock, water, and air between deep Earth and the surface would stop. Life would slowly change, and the world would stop renewing itself. All these things, mountains rising, volcanoes erupting, ocean trenches deepening, land changing shape, are the result of plates moving toward each other. None of this can be seen in one day or even one year, but the records in rocks, in the shape of the land, and even in the stories of people who feel earthquakes or see volcanoes show that this process never stops. The way the land changes at the edges of the plates is a sign of the planet's power to remake itself. Every new volcano, every earthquake, and every mountain started as the result of plates moving, colliding, and pushing one plate down under another. This constant change and recycling explains why the world today is full of tall mountains, deep trenches, and never-ending surprises. When tectonic plates move, they do not always push against each other. In many places across the surface of the Earth, two plates are slowly being pulled apart. This movement away from each other creates a gap, and something must fill the space that opens up. Most of these places where plates pull apart are found deep under the oceans, far from where people live. The results of these quiet movements are some of the most important changes to the planet. As the two plates move away from each other, hot material from beneath the Earth rises to fill the gap. This material is not like the hard rocks you see on mountains or valleys. It is hot, soft, and melted deep in the Earth. Scientists call this material magma. The magma moves upward because there is less pressure above it when the plates pull apart. When magma reaches the surface at the bottom of the ocean, it cools down very quickly. Water from the sea takes away its heat, and the magma turns into solid rock. This new rock is called basalt, and it forms the ocean floor. Every time the plates move a little, more magma rises and cools, making more new basalt. Over a long time, this process builds chains of underwater mountains. These mountains are called mid-ocean ridges. A mid-ocean ridge is a line of high ground that runs along the bottom of the ocean in many places across the world. The ridges can be longer and taller than any mountains seen on land. The biggest of these is the Mid-Atlantic Ridge, which runs right down the center of the Atlantic Ocean. This ridge is so long that it reaches from close to the Arctic, near the top of the world, all the way to the southern tips close to Antarctica. The creation of new ocean floor at mid-ocean ridges is one of the most important ways the Earth recycles itself. As two plates pull apart, new land always forms between them. This is why the seas can grow wider over millions of years. The Atlantic Ocean, for example, is slowly growing as the North American plate and the Eurasian plate move away from each other and new basalt forms at the center. Even though this process happens far below the sea, the effects are very large and important. The old rocks of the ocean floor are pushed farther away from the ridge as more new rock forms. The process is slow. In about 100 years, a plate might move only a few meters, but after millions of years, the ocean floor can move far from where it began. If you could see the bottom of the sea, you would notice that the rocks near the mid-ocean ridge are young, while rocks farther away are older. In some places, the pulling apart of plates happens on land instead of underwater. When this occurs, the land cracks and pulls into deep valleys called rift valleys. An example is the East African Rift, which stretches through many countries in Eastern Africa. In the rift, the land on both sides is slowly moving apart, making a long and deep valley. Over millions of years, the rift might become filled with water to form a new ocean. When the plates move apart, not only is new rock made, but gases from deep inside the planet also escape. These gases, such as water vapor and carbon dioxide, rise into the ocean or the air. This slow release helps balance the gases in the air and the sea, which is important for life on Earth. As magma keeps rising and cooling at the mid-ocean ridges, it also warms the water nearby. In some areas, hot water bursts out from openings on the ocean floor. These openings are called hydrothermal vents. The water coming from the vents is filled with minerals and chemicals from deep inside the earth. Even in total darkness and deep cold, there are living things that grow near the vents. These small creatures do not need sunlight. Instead, they live off the heat and chemicals from below. Some of these animals are not found anywhere else on Earth. The life found at hydrothermal vents shows how important the slow creation of new rocks and escape of gases is for the planet. These places are home to new types of animals, showing that Earth can support life in ways that are very different from land and shallow water. When plates continue to move apart, the ocean floor can become much wider. In the Atlantic Ocean, for example, the distance between South America and Africa is greater today than it was in the past. Scientists know this by measuring new rocks formed at the ridge and using special machines to track the very slow movement of the plates. Not all mid-ocean ridges are the same. Some of them rise high above the sea floor, while others are smaller. The speed at which plates move apart also changes from one place to another. Where the plates move apart quickly, the ridges can be wide and shallow. Where they move slowly, the ridges are narrower and can be very deep. In some places, islands are formed when the volcanoes along the ridges grow high enough to reach above the water. The island of Iceland in the North Atlantic is a piece of the mid-Atlantic ridge that is high enough to be above the ocean. On Iceland, you can see new land being formed, feel the ground shaking with small earthquakes, and watch steam and hot water rising from cracks in the earth. Sometimes, when a very large amount of magma rises quickly and cools, it can cause big changes to the ocean and even the climate above the sea. In the past, large eruptions at mid-ocean ridges have sent gases and dust high into the air. These events can affect the weather, cooling the planet or changing rain patterns. The movement of plates apart and the formation of new ocean floor does not happen in isolation. As new rock is created at a ridge, the old rock far from the ridge must go somewhere. Over a long time, the new floor pushes the old floor across the oceans until it reaches a place where it is pulled back down into the earth at a subduction zone. In this way, the ocean floor is always being renewed. The newest rocks are found at the ridges, while the oldest rocks are found near the deep ocean trenches close to the continents. This never-ending cycle, new rock forming at the mid-ocean ridges, old rock sliding down into the deep at subduction zones, keeps the surface of Earth fresh. Without it, the seas would stay the same and land would become older and less active. Movement of plates apart also influences the position of continents. When new ocean floor is created, continents are moved farther apart. South America and Africa, for example, were once joined together. As the Atlantic Ocean grew wider with new rock forming at the mid-ocean ridge, these continents drifted away from each other. Fossils of the same animals and plants are found on the coasts of both continents, showing that they were once part of the same land mass. Science has made it possible to measure these tiny movements with precision. Satellites in space and sensors on the ocean floor can track how far the plates move each year. The process is very slow, but it adds up through the ages. When lands move apart and new sea floor forms, important changes happen on the surface. Weather patterns can shift as the oceans get wider. New sea currents form, changing how heat and water move around the world. With every centimeter of new rock formed under the sea, the whole planet feels the effect, even if it takes many thousands or millions of years. New land formed at the ridges can build up extra minerals and elements. When the seawater touches the fresh rocks and vents, important chemicals enter the ocean. These chemicals help support the smallest forms of life. Over time, all living things in the sea depend on these small but steady changes. On land, the opening of a rift valley can also make lakes, hot springs, and even new volcanoes. In the East African Rift, there are many deep lakes, like Lake Tanganyika and Lake Malawi. These lakes formed as the land pulled apart, and they are some of the deepest and oldest lakes on Earth. They hold many types of fish and animals found nowhere else. Where the rift valleys are wide and deep, people often find fertile ground. Heavy rain can fill the rift, making rivers and lakes. The new soils left behind by volcanic eruptions or the breakdown of new rocks give plants a place to grow. In many parts of Africa, people live and farm near the rift valleys because the land is rich. Earthquakes can happen at the places where plates pull apart, though they are usually not as strong as earthquakes where plates crash together. These small earthquakes happen because the rock can break and move as the plates shift. On land, people can feel these earthquakes and see cracks in the surface. Underwater, the shaking can make waves and move sand on the sea floor. As the plates continue to drift apart, the planet's face keeps changing. What is land today may become ocean in the future. What is water now may become land as new rocks pile up or islands rise above the sea. The movements do not stop, and the process of making new crust at mid-ocean ridges continues without end. The stories told by rocks on the bottom of the ocean show patterns of spreading and creation. Magnetic minerals in new rocks line up with the Earth's magnetic field at the time they cool. Over the ages, the direction of magnetic lines has changed. Scientists can match the patterns on both sides of the mid-ocean ridges to tell how far the plates have moved and when the new crust formed. Creation of new crust does not just affect the deep seas. As plates move and new land forms, whole continents shift. Over millions of years, this can open new connections between oceans or close them. When the Atlantic Ocean first opened, it allowed new currents to flow between north and south, east and west. This changed where warm and cold water traveled, making new climates for plants, animals, and people. The slow and endless growth of new ocean floor at the mid-ocean ridges is a powerful force. It has split continents apart, created islands, and changed the flow of oceans and the air above. Without this spreading and forming of new land, the planet would not be as active or as full of life. It is why the world never looks the same for long periods, even if the changes are too slow for most people to see. When plates move apart and magma rises to make new land, the world gets new places for plants, animals, and even people to live. The cycle of making new crust and pulling old rock away makes sure the Earth always renews itself. The deep seas are not empty, silent places. They are full of activity, creation, and life. In all the oceans on Earth, there is a line of ridges where new land is born. Every second, small amounts of magma rise up, cool, and become strong enough to build new surfaces. The life, water, air, and land of the planet are all touched by this silent, steady force. The process of ocean ridges spreading and new land being formed is one of the main engines that keeps the planet fresh, changing, and filled with life. As the plates keep pulling away from each other at the bottom of the sea and sometimes on land, the Earth continues to shape itself, building and remaking places for life to grow and thrive. The creation of new land at the ridges, along with the recycling of old rock back into the depths at subduction zones, shows how everything on Earth is connected by the slow dance of moving plates. In many parts of the world, tectonic plates do not only crash together or move apart. Sometimes two plates slide alongside each other. This sliding movement also shapes the planet in powerful ways and can cause some of the most sudden and surprising events we know. When plates move past each other, their edges touch. The plates do not glide smoothly because their surfaces are rough and jagged. As the plates try to move, they often get stuck, the edges catch on each other, and the movement stops for a while. But the forces that push the plates do not go away. Pressure builds up where the plates are stuck. This can go on for many years, sometimes for decades or even longer. Finally, the pressure becomes so great that the plates break free and suddenly slide past one another. This sharp movement releases energy in the ground. The release of energy makes the surface shake. These sudden shakes are called earthquakes. Earthquakes can be small and gentle, making the ground move only a little, or they can be very strong, knocking down buildings, bridges, and roads. The places where two plates slide past each other are marked by cracks in the earth called faults. Faults are found both on land and under the sea. The most famous of these is the San Andreas Fault in California, in the United States. Along this fault, two very large plates, the Pacific Plate and the North American Plate, slide past each other. Many cities and towns are built close to the San Andreas Fault, so when an earthquake happens, a lot of people can feel it. Not all faults are as large as the San Andreas Fault, but the result of any fault can be the same. As the plates move, break, and slip, they cause shaking that can be felt near the fault or even far away. The amount of shaking depends on how much the plates moved and how deep in the earth the sliding happened. Earthquakes do not only make the ground move, sometimes the land itself can break open. In strong earthquakes, roads and fields can split and move in different directions. Fences, railways, and pipes buried in the ground can break apart. Bridges can collapse, and buildings can fall if they are not built to stand the shaking. This is why in places with many faults, people try to make their houses, schools, and hospitals stronger and safer. When an earthquake happens under the sea, it can push up the water and create a very large wave called a tsunami. Tsunamis can travel fast and reach land far from where the earthquake started. When the waves hit the coast, they can flood towns, destroy farms and houses, and move whole boats and cars. Tsunamis can be some of the most dangerous results of plate movement. Most earthquakes happen suddenly and give little or no warning. Scientists can measure movements in the ground with special machines, but there is usually no way to know the exact moment an earthquake will take place. However, scientists know which areas of the world are more likely to have strong earthquakes. These are the places where plates touch and slide past each other or where plates crash or pull apart. Even small earthquakes can cause damage. Cracks in the ground can break pipes and wires. Water can stop flowing, and electricity can be lost. This is why cities in earthquake zones prepare for these shocks. They have emergency plans and teach people what to do if the ground starts shaking. Earthquakes are measured by how much energy they release and by how strong the shaking feels. Some earthquakes are so small that people cannot feel them, but scientists' machines can still measure them. Other earthquakes are very large and shake the ground for a long time. The biggest earthquakes can cause damage over hundreds of kilometers. After a strong earthquake, small shakes called aftershocks usually follow. Aftershocks can happen minutes, days, or even weeks after the big earthquake. Although they are usually smaller than the main earthquake, aftershocks can still damage buildings and scare people who live in the area. When plates slip past each other, the line where they meet is not always straight. Sometimes, faults bend or jump. This can make the ground move up, down, or sideways. Over many years, the land near a fault can look different. Hills and valleys can form, rivers can change direction, and lakes can appear or disappear. The land is always changing, even if the movements are very slow and hard to see. Faults are found all over the world. Some can be seen as long straight lines on the surface of the ground. Others are hidden by forests, cities, or water. Scientists use maps, satellites, and ground machines to find faults and watch how they move. This information helps builders and government leaders keep people safer. The most important thing about faults and earthquakes is that they show the ground beneath our feet is not still. The power stored in moving plates is invisible most of the time, but it can be very strong. Earthquakes remind us that the world's surface is always in motion, shaped by forces very deep below. Sometimes earthquakes can be large enough to move land by many meters in just a few seconds. Roads and railways can shift far apart, and pieces of ground can end up higher or lower than before. These changes can happen in the blink of an eye and make a lasting mark on the surface. Earthquakes not only destroy, but they also build. With each slip, old rocks are broken and new cracks are formed. Over millions of years, the steady action of earthquakes can create mountains, valleys, and ridges. New land can be pushed up or dropped down. As water moves into cracks, rivers, streams, and lakes can form. Plant seeds can fall into open spaces, and new life can begin where the ground once was still. In some places, the movement along faults is so strong that it has become part of people's lives. They design roads, schools, and hospitals so that they can keep standing even when the ground moves. People in earthquake areas have drills and practice hiding under tables or outside in safe places. These actions help save lives and reduce injuries. Much of what we know about faults comes from careful study of earthquakes. Scientists use instruments called seismometers to measure shakes. By looking at the size, length, and speed of the waves made by earthquakes, they learn about the kind of fault below the ground and how it moves. Faults do not only form where plates slide, they also form when plates crash into each other or pull apart. These other types of faults can also cause earthquakes, but sliding faults are special because the movement is side by side, not up and down. The movement can be fast or slow, big or small. In some parts of the world, plates move past each other slowly and only small earthquakes happen. In other places, the plates stick tightly and all the pressure releases at once in a big shake. The way a plate moves depends on how rough the edges are, how fast the plates are moving, and how strong the pushing or pulling forces are. Sometimes the ground on one side of a fault will move several meters farther north or south in only a short time. This means that after a big earthquake, the land itself can be a little different than it was before. Over a lifetime, people may notice fences or trees that were once straight lines now bend or split because the ground beneath them moved during many earthquakes. When strong earthquakes happen, scientists and helpers rush to the area. They check buildings, roads, and water pipes. They help find people and pets who might be trapped. Help can come from other cities, countries, or even from groups in other parts of the world. Tsunamis from earthquakes under the sea can be very dangerous for places far away from the fault. The strong waves move quickly and in some cases only give people a few minutes or hours to find safety. Some countries have alarms and warning systems to help people get away from the water before the wave hits. Earthquakes can also bring changes to the way people live. After a big earthquake, people must fix roads, rebuild schools, and sometimes find new homes. They plant gardens and repair power lines. They think about how to make everything safer for the next time. Faults and earthquakes are important for science too. By looking at earthquakes, scientists can map how plates move, learn about deep layers of the planet, and even find new resources underground. Studying earthquakes helps us learn about how the Earth works from the inside out. The shaking of faults is not only a problem for people. It also moves rivers, builds new hills, and makes space for plants and animals. Many kinds of animals can sense small shakes before people feel them. By watching animals and special machines, sometimes scientists can get clues that an earthquake may be coming, although it is never exact. In places where plates slide past each other, the land can have many small hills and deep cracks. Over millions of years, this land looks different than other places. Long, straight valleys and ridges may show where the faults have moved the most. Sometimes old riverbeds are cut off by earth moving along a fault, making springs and pools. Because the earth is always moving, there are earthquakes somewhere every day. Most are too small to feel, but big earthquakes happen each year, shaking cities, forests, and mountains. The study of earthquakes is called seismology. Scientists in this field work together around the world, sharing information to help keep people and places safer. Building safe buildings and good emergency plans is very important in places near faults. Houses with strong frames, deep foundations, and flexible materials do better in earthquakes. Schools and hospitals are made stronger so they stay safe when shaking comes. People talk with neighbors about where to meet if there is a quake and what to put in emergency kits. Learning about faults and earthquakes also helps us understand how the earth is always renewing itself. Each shake breaks old rocks, moves soil, and lets water reach deep into cracks. These small changes add up over a long time, making landforms like hills, basins, and lakes. In the future, the movement of plates and the slipping of faults will keep shaping the world. Continents will keep drifting, new faults may open, and old ones may stop moving. Earthquakes will still shake the ground now and then. The careful work done to prepare for earthquakes and to study the way the earth moves will always be important for protecting life and understanding the world. The action of plates sliding, sticking, and slipping past each other is only one part of how tectonic plates shape the planet. Along with creating new land at ridges and destroying old land at subduction zones, the shaking of faults keeps the planet alive, changing, and full of surprises for plants, animals, and people everywhere. The changes caused by moving plates do not end with earthquakes, volcanoes, and new land created at the bottom of the ocean. Another very important way plates shape the world is by building mountains and making some of the deepest places in the seas. These tall mountains and deep ocean trenches are easy to see on a map, but they are made by processes that happen slowly and quietly over millions of years. When two plates push against each other but neither one goes under the other, something different happens. The force from the two plates meeting causes the rock at the edges to crumple and fold. If the movement is strong and happens over a large area, all the layers of rock are pushed upwards. This is how mountain ranges are formed. These mountains grow little by little as the plates keep pressing together. The rocks are lifted higher and higher above the land around them. Many of the world's greatest mountain ranges were made this way. The Himalayas in Asia are the tallest mountains on Earth. They were formed because the plate carrying India pushed into the plate carrying Asia. Neither plate went under the other, so the land rose up and made huge peaks. Today, the Himalayas are still rising, though the movement each year is very slow. The process has been going on for millions of years and will keep happening while the plates move. Mountains are also formed in other places where plates meet, but do not always look the same. Some mountain ranges are made when plates slide past each other and old rocks are lifted up. Others are made where plates move apart and leave gaps, allowing new rocks to build up as volcanoes. But the highest and longest mountain ranges are almost always found where huge plates push against each other and none goes below. These tall mountains do not just change the land, they also change the way air and water move. Because mountains are so high, they can block winds and clouds, making one side of the mountain wet and the other side dry. Rain falls more on one side, and the other side often has deserts or dry land. Rivers start in mountains, flowing down into valleys and plains. The cold tops hold snow and ice, which can take many years to melt and flow into rivers. These rivers bring water to cities, farms, and forests far away from the mountains. The slow lifting of mountains also makes the air on top cold and thin. Many plants and animals cannot live at the highest points, but others have adapted to survive in the cold, windy heights. Some animals grow thick fur, and some plants hug the ground to avoid the wind. People have learned how to live and even farm in the valleys and slopes of these mountains for thousands of years. The rise of mountains does not go on forever in the same way. Once the rocks are lifted up, they start to face rain, ice, sun, and wind. These forces slowly wear down the high peaks. Rock breaks into small pieces, which roll down into rivers and are carried far away. Over millions of years, high mountains can become rolling hills or flatlands as they are worn away, even while new mountains are rising somewhere else. Deep under the sea, the movement of plates also creates very deep places called trenches. Ocean trenches are made where one plate moves under another in the process called subduction. The trench is the place where the plate begins to sink. These trenches are the deepest parts of the world's oceans, much deeper than the tallest mountain is high. The Mariana Trench in the Pacific Ocean is the deepest trench ever found. You could put Mount Everest, the highest mountain, into the trench and still have water above the peak. These deep places are very cold and dark. Few living things can survive there, but some strange animals and tiny forms of life have been found using special ships and cameras. The formation of these trenches also creates large chains of volcanic islands and deep, rough floors around them. As one plate slides under, it melts, allowing magma to rise up and form islands, volcanoes, and undersea ridges. Areas around these trenches often have many earthquakes and eruptions, showing that the ground is always changing. Over time, the shape of continents and seas is changed by mountains and trenches. When a continent is pushed up by plates crashing together, the new land is high and can change how water flows across the whole area. When a trench is formed, the sea above it becomes deeper, and the movement of the waters above can be different. The rise and fall of the land shapes where people can live, where animals make their homes, and how plants grow. Some of the world's most fertile fields are found in mountain valleys, where rivers have brought rich soil from above. Many cities were built along rivers that begin in high mountains. People depend on these rivers for water, energy, and travel. The high places and deep valleys made by moving plates do more than make pretty views. They also affect the weather. When air rises up the mountains, it cools and drops rain or snow. This rain fills streams and lakes. The shape and height of the mountains can even help protect land from strong winds or storms. As mountains rise, they may also trap air and water. Some valleys are surrounded by mountains and so collect rain, becoming green and filled with life. Others may stay dry if the mountains block clouds from reaching them. The pattern of mountains and valleys influences everything from forests to deserts, from farms to wild places. Mountains are not only found on land. Under the ocean, the world is filled with underwater mountain chains. These are mostly formed where plates move apart and magma rises to build new land at mid-ocean ridges. The ridges rise up from the seafloor and can be higher than any land mountain, but most are always covered by deep water. Sometimes, parts of these ridges break the surface and form islands like Iceland. Life around these underwater mountains can be very special, with creatures that live near hot vents deep under the sea. The slow building of mountains and deepening of trenches is a sign that the earth is always changing, inside and out. Every year, as plates move a little bit, land is raised in one place and dropped in another. Even when change cannot be seen in a lifetime, the rocks and landforms remember how the plates have moved for millions of years. When high mountains are formed, they can collect thick ice and snow. These become glaciers, which slowly move down the mountains, carving valleys as they go. The melting ice in warm times feeds rivers that bring water to lowlands far from the high peaks. Glaciers can also carry rocks and soil, leaving behind rich ground when they melt. As trenches form, more than just the land changes. The water above deep trenches often holds fewer living things because it is cold and dark, but special animals have learned to live there. In some places, strange fish and tiny creatures make their homes at the bottom. Scientists use special tools and ships to study these deep places and find new forms of life. The positions of mountains and trenches have also guided the way people travel, trade, and explore. The first people to cross large continents had to find the lowest valleys in mountain ranges or follow rivers. Old paths became important roads or cities because they connected places across the high land. Earthquakes and volcanoes are not the only results of moving plates. By building up mountains and opening deep trenches, plates shape almost every part of the world. This affects where forests grow, where deserts form, and even where cities and roads are built. People living in high mountain regions learn to build differently and move easily across steep slopes. People near trenches and seas learn to fish, travel by water, and sometimes prepare for big waves caused by quakes. Each time people look at a mountain or see pictures of the deep ocean, they are looking at marks left by moving plates. The rocks on the top of mountains can sometimes have shells and signs of sea animals, showing that these rocks were once under the ocean before being lifted up. In the same way, flat land near the sea can become high cliffs as new mountains rise or landfalls during movement. Over millions of years, the highest peaks may be worn down to low hills, and deep trenches can be filled or changed. The cycle of lifting, breaking, and sinking never completely stops. Every new mountain or deep valley is a chapter in the long history of the Earth's changing skin. Many countries in the world have big mountains that came from the movement of plates. The Alps in Europe, the Andes in South America, and the Rockies in North America were all formed as plates came together and pushed the land upwards. People visit these mountains to see their beauty, climb their peaks, and use the water and land they give. Mountains and trenches are also home to many kinds of animals and plants that do not live anywhere else. As land rises, new environments are created. Some animals move higher up the slopes, some live only in the valleys, and some plants can grow only at a certain height or in a certain type of soil left by old glaciers or rivers. The endless rise and fall of the ground also makes earthquakes and landslides more likely in some places. When heavy rain falls on steep mountain slopes, the loose rocks and earth can race down into valleys, sometimes causing damage to homes, roads, and fields. Building in mountain areas or near deep trenches takes special planning. Roads and tunnels must be strong enough to handle the shaking of earthquakes and shifting land. Cities in valleys need to be ready for flooding from rivers or melting snow. All these factors are linked to how plates have shaped and keep shaping the land. The air, water, life, and landforms we see are all connected to the slow but steady power of plate movement. These changes give the world its high beauty and deep mysteries. People, animals, and plants all make their lives in the places built by the lifting of mountains and the sinking of ocean trenches. Even when it is quiet, with no earthquakes or eruptions, the plates below are still moving, still building up the peaks and opening new low places. Looking at a world map is looking at a record of all this movement over time, with every mountain and trench showing the Earth's great story. The mountain ranges and ocean trenches are not finished. As plates keep moving, sometimes faster, sometimes slower, the face of the planet will keep changing, rising in some places, deepening in others. The paths of rivers may shift. The pattern of forests and deserts can be altered. As glaciers melt or new ones grow, the water from mountains can change how people and animals live. The movement of plates, with its power to build up and break down, is always working, even if it cannot be seen day by day. The world's greatest heights and deepest places are proof of the Earth's living surface, growing, sinking, and shaping the land for all life. The way mountains rise and deep trenches form is not only important for shaping the planet. These changes from moving plates have a strong effect on life. The air we breathe, the water we drink, and even the weather that brings rain or snow. Plate tectonics does more than move rocks. It makes the world a place where life can start, grow, and survive. Whenever volcanoes erupt or new land is formed, materials from deep inside the earth come to the surface. These materials are called minerals, and many of them are rich in elements that plants and animals need. Some minerals help to make the soil fertile, which means crops, trees, and grass can grow strong and healthy. On the slopes of volcanoes, for example, the ground is often very good for farming because new minerals mix with rain and old soil. In some countries, families build their farms near volcanoes even if eruptions are dangerous, because the land helps them grow more food. When plates move, they do not only change the ground, the movement also controls where water collects. High mountains catch snow and rain. When the snow melts, it fills rivers that flow down to the lowlands. These rivers can travel for hundreds or even thousands of kilometers, carrying water to people, animals, and plants far away. The water brings life to fields that might otherwise be dry. In many places, more than half of the water in rivers comes from the snow and ice of high mountains. When plates move and make high places, the air is cooler at the top. This helps make snow last longer, even in places that are warm during the summer. When the snow or ice melts, it does not happen all at once. Instead, the water flows little by little all year. Some of the world's biggest cities depend on this slow melting to get water for homes, cooking, cleaning, and watering crops. The movement of plates does not just help plants and animals by giving them new land and water. It also affects the air and weather. One of the ways this happens is through volcanoes. When a volcano erupts, it sends gases into the sky. Some of these gases are important for making clouds and rain. Others, like carbon dioxide, help plants make their food. Over long stretches of time, the moving plates help keep the air balanced so the Earth does not get too hot or too cold. If there were no plate movement and no volcanoes, all of the carbon dioxide and other special gases could get trapped in rocks under the ground. Without these gases in the air, the world could get much colder. With too much gas, the Earth would get too hot. Plate tectonics helps keep just the right amount, so plants, animals, and people can live. Volcanoes also bring other gases and elements to the surface, such as sulfur, nitrogen, and iron. When these mix with rain, they help make the ground richer. In time, this rich ground turns into good soil. Forests, grasslands, and farms all depend on the new soil that volcanoes bring. The paths of rivers, shapes of lakes, and even the way the wind blows are changed by mountains made from moving plates. Mountains force the air to rise, which cools the air and makes clouds. These clouds bring rain or snow to one side of the mountain. The other side of the mountain may have much less water, making deserts or dry plains. The places where crops can be grown, where forests grow, and where wild animals live are all shaped by how plate movement controls water. Life in the ocean also depends on moving plates. When new land forms at the bottom of the sea, hot water and minerals rise up from the rocks. This makes a home for special kinds of life, such as tiny microbes, crabs, and long worms. Some of these creatures do not need sunlight at all. They use the heat and chemicals from the earth for energy. These deep-sea places prove that life can grow in dark, cold water, as long as the planet keeps moving and creating new places. Plate tectonics helps life in one more important way. It recycles rock and soil. When an old ocean floor is pulled down at a subduction zone, it melts and mixes with the mantle. Some of this melted rock comes up again in volcanoes, full of new minerals and gases. The world is always being renewed. Old land disappears and new land forms. Plants and animals always have fresh places to live and grow. Because the land always changes, plants and animals must change too. Some animals move to higher places when land rises. Some plants learn to grow in the thin air or cold on tall mountains. Rivers may find new paths, and forests may spread or shrink. Life always finds a way, changing and adapting to the changing world below. Not all change is easy for living things. Large volcanic eruptions can make the air dirty and block sunlight for days or weeks. This can make life hard for plants and animals. Sometimes, weather changes after big eruptions, with less rain or cooler air for a long time. But even after disasters, new plants grow, animals return, and the world becomes green again. Some of the richest soils on Earth come from old volcanic ash. In places like Indonesia, Italy, and Central America, people grow rice, grapes, corn, and other crops in soil made from old eruptions. These people often watch the volcanoes closely because their lives depend on both the danger and the gifts that the mountains bring. When plates crash together and make high mountains, they change the way water flows over the land. New rivers appear, old lakes may disappear, and the paths of streams can be blocked or changed. These changes create new places for fish, birds, and other creatures to live. The rise and fall of mountains makes valleys, caves, and forests where life can spread and grow. The amount of rain and snow that falls and the way it is spread across the earth is shaped by the pattern of high and low land. Mountains brought up by moving plates are like walls that help guide the air, wind, and water. Deserts form in places where the mountains block rain. Wet forests grow where mountains catch all the clouds. All of these things show how the movement of plates shapes the world of living things. Animals also move with the land. Over thousands or millions of years as the continents drift, groups of plants and animals are carried with them. Sometimes groups that were once together are split apart by new oceans or high mountains. They change in different ways, becoming new species. This is why strange animals, like kangaroos in Australia or lemurs in Madagascar, are found only in certain parts of the world. Plants and animals that can travel easily move to new places as land rises or splits. Birds can fly across new seas, and tiny seeds can float on the wind or be carried by water. Other animals and plants stay in the same spot while the land around them changes completely. Over time, every plant and animal alive today has adapted to the new world created by the slow dance of moving plates. When earthquakes or volcanoes damage land and water, people and other living things must rebuild. Crops must be replanted, houses and roads repaired, and forests often regrow from seeds left in the ground. When tsunamis, large waves caused by earthquakes under the sea, flood beaches and towns, new sand and soil are brought in from the ocean. This can create new places for plants to grow and animals to live. The movement of plates does not stop, so all life must always adjust. In many places, people use special ways to keep safe from earthquakes and eruptions. They build stronger houses, plant trees to stop landslides, and teach each other what to do when the ground shakes. People also watch volcanoes closely for signs that they may erupt, so they can leave quickly if needed. All over the world, forests grow in the rich ground of old volcanoes. Lakes and rivers made by moving land hold fish and water for people. Valleys made by shifting plates become big cities. People enjoy climbing mountains, swimming in lakes, or just living in the many different regions made by plate tectonics. Plants and animals continue to surprise scientists with how they can live in even the most difficult places. Trees that grow in cracks on rocky mountains, birds that fly over glaciers, and fish that swim deep in ocean trenches are all proofs that life can always find a way if the planet keeps moving and changing. Some gases released by volcanoes even help to make the sky blue and the sun set in bright colors. The tiny particles in the air make light scatter and change the way we see the world. Volcanoes, earthquakes, mountains, deep seas, and river valleys all take part in making the world beautiful and full of change. The movement of plates also helps keep Earth's climate stable. When volcanoes bring carbon dioxide into the air, it mixes with water and forms rain. Over millions of years, the rain and rivers wash carbon into the oceans where it settles into rocks. When plates move, an old ocean floor drops down into the mantle, the carbon is recycled. This long cycle helps the planet stay warm enough for life. If the plates stopped moving, there would be fewer new places for life to live. The old soil would lose its fertility. The air might get too cold or too hot, and plants could not breathe or make food as well. Rivers would dry up and deserts might spread. By always making new land and bringing up fresh minerals, plate tectonics helps keep the whole world alive. People have learned to use what plate tectonics brings. They find gold, silver, iron, coal, and oil where plates have split or pushed mountains up. They use hot water from the ground, called geothermal energy, to warm their homes and make electricity, energy that comes from the heat of the moving earth. Life depends on balance. If the plates moved much faster or much slower, life would have trouble adapting. But over millions of years, the speed has changed, sometimes faster, sometimes slower, and living things have always found ways to survive. The memory of big eruptions or earthquakes is sometimes kept alive in the stories of families or written in rocks and tree rings. Every mountain, valley, river, beach, and ocean is a result of the way plates move below us. The story of life on Earth is also the story of plate tectonics. The way forests grow, where deserts are, how fish and birds spread, even why some animals live only in certain places, all connects with this slow and powerful process. As people travel, fish, build, and explore, they are always living in a world shaped by these deep forces. The pattern of the land, the richness of the soil, the way rain falls and rivers flow, and even the air we breathe, all come from the ancient and never-ending work of moving plates. The beauty and strength of the living planet can be seen in the tallest mountains and the deepest seas, and in every plant and animal that makes this world its home. All the ways that tectonic plates shape mountains, rivers, oceans, and life on Earth are not just interesting for scientists. For a long time, people did not know why earthquakes or volcanoes happened, or why the land and sea sometimes changed in ways that seemed mysterious or frightening. People made stories to explain big shakes in the ground or fire rising from mountains, but no one truly understood why the planet could be so active. When scientists finally learned how tectonic plates move, everything started to make more sense. Now, many things that people once thought were random or controlled by angry spirits could be explained. If the ground shakes near a fault, or if a volcano erupts near the edge of a plate, it is because of the movement happening deep below our feet. This discovery did not come all at once. It took many years for scientists to collect facts, watch the land, and agree about these new ideas. Some of the first clues came from rocks and fossils. In the early years of the 20th century, scientists saw that the coastlines of Africa and South America looked like pieces of a puzzle. The rocks and ancient animal bones along these coasts matched very closely, even though the land was now separated by a wide ocean. Plants and animals that could not cross the sea still had fossils on both sides. This suggested that the continents were not always in the same place. When scientists began to study the bottom of the ocean using new machines in the middle of the 20th century, they found long chains of mountains under the sea and deep trenches near continents. They also found that rocks near these mid-ocean ridges were very young and got older the farther they were from the ridge. Patterns in the rocks showed that the seafloor was spreading out, with new land coming up and old land moving apart. By looking at earthquakes with special instruments called seismographs, scientists learned that most earthquakes do not happen anywhere by chance. Instead, they happen along lines where the plates meet. Volcanic eruptions were also mapped and found to be most common at these lines. All these facts finally fit together. The Earth's surface is broken into plates and each one is moving slowly all the time. This understanding changed the way science saw the planet. Before plate tectonics, no one could explain why mountain ranges formed in some places but not in others, why volcanoes often appeared in long chains, or why coral reefs and fossils could be found high up in the mountains. Now, with the idea of moving plates, scientists could see that these landforms, shakes, and eruptions all happen because of the same simple process. With this knowledge, people could take steps to be safer. Scientists and engineers studied which areas have the most risk of earthquakes or volcanic eruptions. Governments and builders started to write new rules so that homes, schools, and hospitals would be stronger, especially in places close to faults or volcanoes. Modern buildings in cities like Tokyo, San Francisco, and Santiago are made with special designs that help them stay upright when the ground shakes. Knowing about tectonic plates helps experts find good places to build bridges and roads. It also helps them know where it is too risky to build without strong protections. People living close to active faults or volcanoes learn what to do in case of an earthquake or eruption. Many countries have emergency plans. They practice drills at schools and offices, with families learning where to go and what to take if they need to leave quickly. When scientists watch a volcano, they measure small earthquakes, look for changes in the shape of the mountain, and check for new gases coming from cracks. These clues can show when a volcano is more likely to erupt. If the danger increases, people nearby can be warned to leave the area before an eruption happens. In places close to the ocean, warning centers watch for large earthquakes that might cause tsunamis and send alerts so people can move to higher ground. Before the discovery of plate tectonics, many disasters caused by the Earth's movement happened without warning. Now, with new science and technology, people can often be much safer. The study of tectonic plates helps everyone, not just scientists or people living in special places. It helps us understand how to protect the world's buildings, roads, and resources. Plate tectonics has also made a difference in how scientists find things people need, such as mineral resources or energy. Gold, copper, and other metals are often found near old volcanoes or mountain ranges where plates have moved. Oil and gas collect in places where the rocks have been bent or cracked by plate movement. Knowledge about plates helps companies and countries know where to look for these materials and how to use them wisely. Long ago, no one knew why continents seemed to move across the Earth over millions of years. Today, satellite images and GPS devices let scientists measure those movements very exactly. They can tell if South America is moving further from Africa, or if Australia is moving north, or how fast the Himalaya mountains grow higher. These measurements, accurate to centimeters each year, show that the world is never still. Scientists use the history of plate movement to understand the past and guess about the future. By studying rocks, fossils, and the pattern of earthquakes, they can tell which areas are likely to have new volcanoes, where earthquakes may occur, or how mountains have grown. This helps people plan cities, roads, and farms so they are less likely to be hurt by natural events. Sometimes old knowledge changes because of plate tectonics. For example, ancient maps or legends tell of whole islands rising or sinking. Now, science can explain this. When plates move suddenly or slowly, they can lift land above the sea or let it fall underwater. These changes still happen today, just as they did when ancient people lived by the sea or along big rivers. Plate tectonics has given scientists a way to predict, plan, and prepare. Even with all the new knowledge, it is impossible to know exactly when an earthquake or eruption will start. But it is possible to know which areas have high risk and to prepare for emergencies. This has saved many lives during big natural events. Studying tectonic plates has also changed how we learn about life on Earth. Fossils found in places that are now far apart help show how plants and animals moved as plates carried the continents. By knowing the history of plate movement, scientists track how animals and plants changed when they moved to new places. This helps explain why some animals can only be found in special places, like marsupials in Australia or giant tortoises in the Galapagos Islands. The knowledge of plate tectonics not only helps keep people safer, it also helps care for the land. Scientists can use this understanding to predict when rivers may change their paths, when mountains may grow or shrink, and how the soil will stay rich or become worn out. Farmers, builders, and city planners use this knowledge to plant crops, design safe homes, and build cities that last. This new science has joined people from all over the world. Researchers from America, Europe, Asia, Africa, and many islands work together, sharing data from earthquakes, volcanoes, and the slow drifting of continents. Science brings people together in the search for understanding and helps protect everyone against nature's surprises. Plate tectonics explains why so much on Earth is always changing. The air, the oceans, the shape of cities, and even how people live are all connected to the movement of plates. The rules used for building are better because engineers have learned from watching earthquakes and eruptions. New technology like satellites and sensors helps people all over the world see when and where the ground is moving. Knowledge from plate tectonics reaches classrooms, news, and public talks, teaching millions of people about their world. The more people understand the movement of plates, the better they can respect and live with the natural events that happen. Living in a world full of mountain ranges, volcanoes, and shaking ground can sound frightening. With good science, careful planning, and strong buildings, People learn to work with the Earth, not against it. Plate tectonics does not only warn people about dangers, it also inspires wonder and helps everyone appreciate the beauty and variety of the world. School children learn how the continents travel over time. Travelers and hikers see the power of plates in great rift valleys, volcanic islands, high rocky peaks, and unique beaches built by the changing Earth. Artists, writers, and poets have all found ideas and beauty in the land's changes. Knowledge about tectonic plates is also used in planning for the future. As the climate changes and sea levels rise, understanding how plates, mountains, and trenches affect water and weather helps cities plan how to protect coasts and people. Knowing where rivers may flood or where land may shake can help keep people and their homes safer. When disasters do happen, recovery is faster because of what scientists and planners have learned. Emergency plans, safe evacuation routes, and strong communication help people survive, find help, and rebuild. Nations send aid to each other, share ideas, and give support when floods, landslides, or earthquakes strike. This science has grown in recent decades as new methods make plate movements easier and quicker to understand. Machines on the ground, ships at sea, and satellites in orbit all work to show how the land moves. Simple devices in schools or city centers help children and families learn to read the signs of movement. This education helps save lives and brings new respect for the living planet. The story of plate tectonics has also helped discover how other planets might work. By looking for cracks, volcanoes, or high mountains on Mars or Venus, scientists try to compare them with what is seen on Earth. This helps teach about planets everywhere, not just our home. Understanding how the pieces of Earth move also helps prepare for new challenges. When building new roads, schools, or dams, people take into account the movement of the land, the risk of shaking, and the history of volcanic ash in the soil. Knowing where water is stored underground, where slopes may move, or where deep cracks might appear can save money, time, and lives. The story of plate tectonics is a story of discovery, safety, and connection. It is also a story of care, learning to live with fire, water, earth, and air in a way that respects the forces deep below. Everyday life, from where people get water to how food is grown, is shaped by this understanding. As plates keep drifting and the world's surface keeps renewing, the lessons from plate tectonics will always be useful. The land will still shake, mountains will still rise, and volcanoes will still erupt. But now, because of the work of many people, the world is less mysterious, and people are better prepared to face what nature brings. This way of thinking changes not just science, but also the way people see their home and their place on the planet. Recognizing that the Earth is always alive and changing means people learn to respect the land, take care of each other, and plan wisely for the future. The knowledge of plate tectonics continues to grow, ready to help people face each new day and the surprises that the living Earth may have ahead. The surface of the Earth stays alive and new because tectonic plates keep moving every day and every year all over the world. The movement of these plates never stops, not even for a second. Sometimes the movements are fast, shaking the ground in an earthquake or bursting up in a volcanic eruption. Other times the movements are gentle and happen so slowly that no person can notice them. But over thousands and millions of years, these small and steady changes add up to shape everything we see. Old rocks do not last forever on the surface. Over time, many of them are pushed down into the deep earth at places where plates meet and one plate goes under another. This is called subduction. The old rocks get hotter and softer the deeper they go. After a long time, they melt into the thick, moving inner parts of the planet. Once that happens, they are not lost. The material becomes part of the Earth's engine, sometimes rising again far away as magma and forming new land when it cools. At the same time, new rocks are always being created somewhere else. Where plates move apart, such as at mid-ocean ridges deep in the sea, hot material from inside the Earth rises up. When this material touches the cold ocean water, it cools quickly and becomes solid new rock. This process never ends. Even now, new rocks and land are forming at these places. The rocks then begin a long journey across the ocean floor, carried by the slow drift of the moving plates. Because old rocks disappear into the deep and new rocks are created on the surface, the skin of the planet is always being replaced or recycled. This is the great cycle of plate tectonics. It explains why the land and the sea never look exactly the same from one age to the next. The face of the Earth is full of clues about old mountains, vanished seas, and the long journey of continents. The effects of this constant recycling are seen in every part of the world. Tall mountain ranges, deep ocean trenches, long valleys, rocky coasts, wide plains, and even the shape of islands are all shaped by the building up and wearing away of land caused by moving plates. As the plates travel and change, they create places for new life. They carry the plants, animals, and people who live on the land to new environments, over wide spaces and through long ages. No other planet in our solar system has the same pattern of moving plates as Earth. This constant action makes our world special, keeping it active and good for life. The new land that rises and the old land that melts provides minerals and fresh soil so that forests can grow, crops can be planted, and animals can find food. The rivers that begin in mountains or cross valleys bring clean water, shaped by millions of years of plate movement. The endless action of plate tectonics is not just about big events or dangers. It is also gentle and slow, shaping coasts, smoothing hills, and filling low places with new earth. Rain, wind, rivers, and ice help break down rocks that are pushed up, turning them to soil and sending them to new places. The sand on beaches, the mud in rivers, and the rich dirt in fields are all part of the slow recycling of the Earth's outer layer. Every mountain, every flat plain, and every deep-sea valley tells a story of creation and destruction, of building up and breaking down. These stories are written in the rocks, in the shells of sea animals found on the highest mountain tops, in the sharp edges of volcanoes, and in the deep layers of soil. Plate tectonics links together many of the planet's important cycles. The sun and rain help shape the surface, but it is the moving of the plates that decides where the land will be high or low, dry or wet, rich or poor in minerals. Where plates come together, mountains and volcanoes rise. Where they pull apart, new oceans and valleys grow. Where they slide past each other, earthquakes shake the land, sometimes changing the flow of rivers or making new lakes. The movement also helps the air and water stay fresh. Volcanoes and new rocks release gases and minerals, keeping the air just right for plants and animals. When old rocks go deep underground, some gases are pulled down and then rise again in new places. This long cycle helps keep the temperature of Earth safe for life. Many things that people use and enjoy come from this cycle. The fertile soils that make it possible to grow food come from mountains that were lifted by the plates, then worn down and carried to flat land by water and wind. The metal for tools and machines is found in rocks made by old volcanoes or brought up at the edges of moving plates. Even the energy for homes and factories sometimes comes from deep inside the Earth, where heat from the plates moving provides power. The world where people live is always changing shape, even if those changes are hard to see in one lifetime. Sometimes new islands rise from the sea. Sometimes big lakes appear or disappear when land is lifted or dropped by the moving ground. History has stories of whole cities that were flooded, buried by ash, or lifted up by silent, slow movement of the plates. The process of plates breaking, building, melting, and renewing has given the world its highest beauty and deepest mysteries. From the green valleys where rivers wind to the sharp cliffs above the sea, every piece of earth is the result of this unstoppable, invisible force. The ocean floors are young, never more than a few 100 million years old, even though the earth itself is more than 4 billion years old. The continents are older, but still always on the move, joining together then breaking apart over long ages. Scientists call the coming together of all continents a supercontinent. Once, all land was joined as a supercontinent called Pangaea. Over time, the plates pulled it apart, spreading the continents across the world. In the far future, the plates may bring the continents together again in new shapes. Every year, new discoveries show how the movement of the plates continues to change the world. Satellites high above Earth measure the smallest shifts in the land. Deep-sea robots explore the new mountains and ridges at the bottom of the oceans. Scientists dig up rocks to read the stories written in their layers, finding clues about volcanoes, ancient forests, floods, and deserts that lived and vanished long ago. People, animals, and plants have always lived on a planet that never stays the same. Sometimes the changes are quick, like an earthquake, a landslide, or a volcanic eruption. Sometimes the changes are slow, with land rising or falling by only a small amount each year. In both cases, the living things find ways to adjust, adapt, and survive. Plate tectonics makes the world dangerous but also safe because it brings new land, new water, new soil, and new ways for life to grow. The world's mountains and valleys, rivers and lakes, deserts and forests all depend on the endless work of moving plates. Even the air, by carrying rain and wind across the land, is connected to the way the ground rises and falls. The beauty of the natural world, the places people visit to climb or hike, swim or sail, farm or build homes, is part of the gift of plate tectonics. Many people use what the earth gives without thinking how it came to be. The food in a field, the water in a stream, the stone in a building, and the gold in a ring all have a past that began deep inside the moving planet. The plates under the ground move slowly, but they do their work every day, shaping the world for the future. Learning about plate tectonics helps people understand the world and use it wisely. Knowing where earthquakes can happen, why volcanoes form, or how mountains rise lets builders create safer homes, roads, and cities. It helps farmers choose the best places to plant seeds and raise animals. It teaches leaders to protect forests, rivers, and lakes, not just for today, but for many years to come. The cycle of creation and renewal by moving plates is the power that keeps Earth alive. It brings both dangers and blessings. Without it, the world would be flat and quiet, with less water, fewer mountains, and not as much life. Rain would fall in different ways, rivers would not run as far, and the air might not be right for plants or people to breathe. Because new rocks are always being made, old land never becomes too tired for life. Each time new soil comes to the surface, new forests and grasslands can grow. Each time a volcano brings up new minerals, the land becomes richer. Animals have new places to roam and people have new places to build. The story of plate tectonics is the story of the Earth making itself again and again. It is about motion, energy, change, and growth. It is the silent force that shapes the path of rivers, the rise of mountains, the fall of valleys, and the journey of continents across the globe. In the future, the plates will continue their endless journey. There will be more earthquakes and eruptions, more flooding and new land rising from the sea. But there will also be new forests growing, new animals finding homes in valleys and on hills, and new cities built in safe and beautiful places. Knowledge of plate tectonics joins the past, present, and future. It explains the old history of the world, helps people solve problems today, and shows how the Earth will change tomorrow. As long as the plates move, the land is made new again and again. The power of this movement has given the world its shape, its life, and its endless beauty. With every sunrise and every day that passes, the plates under the surface continue their quiet work, breaking, building, shifting, and making the planet new. The world is alive because plate tectonics never sleeps. The creative and recycling force under our feet is the reason there is a place for every living thing, a place for people to build, explore, learn, and hope. The never-ending force is the true creator of the world we all share.